triple, from the current roughly 4,500 standard container limit to roughly 12,000 standard containers. These changes will make the Panama Canal more competitive with the alternative Suez Canal route, which currently accommodates much larger ships.
So there is a story about Panama Canal extension. It is already finished, so now it's operating. Several years ago. And this is a drilling ship. Oh, what is this? Oh, this is a research ship. Research ship from probably Japan. And the weight of the ship is 57,000 tons, length 210, and breadth is 38 meters. And the tower height, at the center of the ship, there is a tower. Tower height is 130, and depth is 9.2. And then the travel length is 40,000 nautical miles. This is important because the research vessel needs to travel far away to say Arctic Ocean and stay there for a long time, months, so that the fuel oil needs to be enough to stay long traveling. Right. That's why this is important number here in research vessel. And maximum number of passenger or researchers is 150 person. The speed is not high, 12 knots. And this is the arrangement of oceanographic research ship. Number 1, navigation bridge, public space, accommodation, forepeak, storage, double bottom, engine room, and steering fuel oil tank is 11, potable water tank. And also there is a video. Let's see.
70% of the Earth is covered by the ocean, and the ocean interacts with the atmosphere and the land. Those interactions control the world we live in.
Some of the most important questions facing society includes climate change, the future of food supply, sea level rise, geohazards such as earthquakes and volcanism along coastlines. It's very important to understand the basic scientific underpinnings of all these different processes.
Being able to go out to the ocean and make observations is the most critical component of oceanography. And it's going to rely on new vessels with new capabilities to use the ship efficiently and gain the maximum benefit for the most people.
When we were approached by Oregon State, one of their key objectives was to make this as green a ship as possible. We've gone to great lengths to incorporate the latest technologies into the ship to keep it as environmentally friendly as we can.
We've decided to use variable speed alternators to make electricity. We've also used LED lighting wherever possible. We're using waste heat, so the heat from the engines, we'll use that to heat domestic water and to actually make potable water for the ship.
The design of the ship is very, very important to the efficiency of the ship. And so we went to great lengths to make this as low resistance hull as we could, in keeping with the desires of the scientists to have bubble sweep down minimized for the performance of their instrumentation.
Part of the design has been to incorporate a U-tube anti-roll tank. And so that means the vessel can operate in more challenging environments, and a lot of our coastal environments do see some pretty severe weather conditions, and we like to be able to investigate ocean processes under all conditions, not just on a sunny day.
We've got a double articulating A-frame, which will allow the vessel to pick up pretty large packages. The launch and recovery system will be designed so that it can put the CTD almost down to water level. They have a centerboard where they can change out some of their transducers. They also have a pretty extensive transducer array. There's always, for this project, been a drive to collect as much data as possible and as continuously as possible.
Data presence is providing real-time data to enable virtual participation to researchers and stakeholders on the shore. So we've got a team assembled that are developing the technologies to enable this. And in terms of moving forward in the 21st century, that's very exciting. And that's where we need to be. The layout was designed to balance people's habitable enjoyment versus the practical requirements of why they're at sea. And every detail on these ships has been scrutinized against the practicality of being underway, doing science at sea. So we put a lot of thought into creature comforts and habitability issues, making sure that they ride well, making them places that people want to be.
I really am passionate about what it is to be on a research vessel. It's a really special opportunity for a scientist, not only to do your science, but to be in a community at sea. I would hate to lose that.
If we're really going to understand and answer questions about our future, how we can leave to our children and our children's children a better planet where food supply is more constant, where people can have clean water, where plants can grow, we really need to understand what's going on in the oceans.
Right? Question? No. Go on to drill ship. Looks similar, but the purpose is different. We already see this one from the ocean engineering. The drill capacity is depth. You see from the picture right hand side, 11 kilometer depth of drilling. It's a big distance. And also you need a dynamic positioning of the ship because the drill pipe should be steady at the given position. Oh, there is another video.
Good grammar and spelling are important, but if you want to write essays that inspire,
How does the deep-sea drilling vessel Chikyu drill into the seafloor? When the vessel arrives at the drilling site, it receives a satellite signal that helps the vessel move into the exact position required. The vessel has 6 propellers that rotate a full 360 degrees and keep the vessel in one position, preventing it from drifting due to the wind, waves, or sea current. First, the conductor pipe is installed. As the drill pipes are connected, the conductor pipe and guide are run down to the seafloor. After the conductor pipe penetrates the seafloor, the drill pipe is released and pulled back to the vessel. A large drill bit connected to the bottom of the drill pipe is run down to the seafloor. The drill bit is led down to the bottom of the hole through the conductor pipe. The drill bit rotates and drills the sediment and rock below the seabed. Seawater is sprayed from nozzles on the drill bit to raise the cuttings to the seafloor. After drilling several hundred meters, the drill bit is pulled back to the vessel. A casing pipe, about 50 centimeters in diameter, is set into the drilled hole to keep it from collapsing. The casing pipe is run down through the conductor pipe and is inserted into the hole using the drill pipe. Cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. After cementing, the drill pipe is released and pulled back to the vessel. The Chikyu is equipped with the riser system in order to drill into the earth even deeper. As the riser pipes are added one after another, the blowout preventer is run down to the seafloor. The blowout preventer is connected to a wellhead which is located on top of the casing pipe. The vessel is now connected to the seafloor via the riser pipe. A drill bit, smaller than the one first used, is run down through the riser pipe and casing pipe. The drilling begins. Once the riser pipe has been connected, drilling mud is used instead of seawater. When the target depth is reached, the drill bit is pulled back to the vessel. To drill the hole even deeper, a narrower casing pipe is set in to protect the drilled hole. After the casing pipe has been installed, cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. Again, an even smaller drill bit is run down through the riser pipe and casing pipe, and the drilling continues. Repeating this process, the Chikyu will drill through the ocean crust.
Here. So you have any information?
So,
yeah,
Professor,
question? Yes.
They drill through the cement every single time?
Well, depending on the situation. But if the soil there is soft, they need some kind of a protection. Otherwise, it can collapse or it can be filled with other material. So it depending on the situation or how long they will use that pipeline or hole. So depending on the situation, they may have different methods to be used.
I was wondering, like after it's done, I mean that spot is it's depleted of the resource they're looking for. So the cement and everything, does that remain, or they like remove that?
They remain, yes.
Okay.
Because otherwise, sometimes the reservoir can be filled, is empty. That can be another problem. So they may need to fill in the reservoir hole as with water sometimes, and then have sealing the hole. So many people are saying or has an idea to use that as a temporary tank for CO2 gases. So it depending on the situation, you can use or you can sealing.
I see.
All right, let's go on to next slide. FPSO, we already see this one. Capacity 2 mega barrel. This is at that time is a one-day use of whole Korea, South Korea, of oil. So you can expect the size. And this one is similar, but this is a floating storage and regasification unit of LNG. So similar to land-based LNG storage facility, but it is a ship type. And sailing yacht. Oh, there is another video. Okay, so let's see. This one. that's a sailing ship or sailing yacht. And this is a motor yacht without any sail. There is an engine room. Number 6 is engine room. The other is a lounge, dining room, guest accommodation, navigation bridge, crew accommodation, storage space. Okay, that's it. So, question? Otherwise, we can go on to discussion session led by Chang Go, please.
Okay. So, can you see my presentation?
Yes.
Okay. So today's discussion is about the general arrangement of the ship. So first question is about the Seoul incident, which is very sad event that occurred in 2014 in Korea. So some experts say that one of the reasons of that incident is overcargoing. So this Seoul is a ship which carry both passenger and cargo. So how can we build the safe ferry that carry both passenger and cargo by proper general arrangement of ship? So if anyone have any idea? Can you?
I think we have to give up some portion. If we take safety, then we have to give up overcargoing if we don't have enough money. Yes, I think getting two of the advantage is impossible. But I think when we cargo the loading at the bottom of the ship, I think ship safety will increase because the center of the loading is lower, and I think safety can increase.
Okay, thank you. So, Sung-yeon say that it is hard to take both advantage of like cargo, a lot of roading, and the safety. And if we want to load cargo, then we have to locate it near bottom to make center of gravity become low. So any other idea about this topic?
Maybe also the passenger seats, they should also be placed towards the base. We see that many times, like say overall, even in our country, there were many cases, and most of the time it's because most passengers would like to see the balcony views and stuff, and they would go upstairs, and too many people upstairs and no one below, like, makes the thing very unstable, and then it would like topple over. So maybe like the restrictions as well on the ships, like no entry beyond this the top level, imposing imposing restrictions like that. And also maybe probably if they, I mean, there has to be strong regulation, right, to make sure that once before the ship takes off, the ship is not below the free length. I forgot the term. The mark on the bottom of the ship, that color mark, should not exceed that. So I think this is more about monitoring rather than design. Yeah.
Yeah, for example, I have an opinion about it. I was just reading about a accident, and it turns out the ship, it was built in 1994, and it was run through a Japanese company until 2012, and then it was sold to Korea, and it worked for like 2 years as a carry, but it had some modifications, and these modifications changed the center of gravity. And the thing is, sometimes these modifications are not supposed to be in the ship, or they're not done properly, so that it can turn out into an accident. And also, I think maintenance is really important for ships, because if you're in the middle of the ocean, you cannot get the same maintenance as if you were just on land. So maintenance is really critical for ships and yachts. So for me, maintenance is important, and that's my opinion.
And also, if the ticket prices or something, and again, I feel it's about monitoring rather than ship design, because ships have been already designed very for long, we have a long history of research in this field, so maybe it's already been designed pretty well, but it's about how we monitor. So maybe if the tickets are very cheap or something, those regulatory committees, I mean, the boards